when they define increasing and decreasing, they define it for x1 is strictly less than x2. And this is purely for your information, but the definition of increasing and decreasing and constant, all three of those definitions have this x1 is strictly less than x2. So if you think about like x is less than 3, how you would draw that inequality, you are going to use parentheses, right? If it's a strictly less than interval, you use parentheses. Well, the thing is, the definition of increasing and decreasing has this strictly less than. So anytime you are reporting increasing and decreasing, you are always going to use parentheses. Okay, so in this section, when we're talking about finding increasing and decreasing, we are never, ever going to use a square bracket. The answer for this is always going to be parentheses x, parentheses x. All right, but it's always parentheses, and that is because of this definition. Okay, so that's just like a very quick notation issue, is that we need to always use parentheses. Now, the other thing that we need to remember is back in college algebra, they would give you a picture and they would say, okay, where is this function increasing? Where is it decreasing? When you try to identify that, you read the graph just like you read a book. Okay, so you read a book from the left-hand side to the right-hand side, and the same thing is going to be true when we read the graph. So going from the left to the right, we're asking ourselves, are we going up the hill, down the hill, or constant? So again, there was that whole thing about like how there's a little man, this little man from left to right is going up a hill, so he is increasing. Meanwhile, a decreasing function, our little guy would be up here and he's going down the hill, so it's decreasing. But again, it's always left to right. So from the left-hand side to the right-hand side, what is happening? And then constant, of course, is that there is no hill. Okay, so that's what we learned about in college algebra, is that it was about like, are you going up the hill or down the hill? Okay, now you guys, here's our goal. Our goal is to figure out where the function is increasing or decreasing without seeing a picture or a graph of the function. And the way that we're going to do that is to connect this to the derivative. So remember, the derivative is the slope of the tangent line. So if I look at an increasing function, so again, if I just look at this increasing function, isn't it beautiful? And I draw myself some little tangent lines. You will notice when you draw these tangent lines that they're all positive slope. You do not have a downward sloping line, tangent line. So there's going to be a theorem that's going to tell us that when this is increasing, the derivative is greater than 0. And you can see that when you draw an increasing function, you see that the slope of the tangent lines are all positive. Now, if you look at a decreasing function and you draw some sample tangent lines, you will notice all of those tangent lines from left to right have negative slope. So that's our next connection, is that when it's decreasing, the derivative is going to be negative. It's going to be less than 0. And then when we have a constant function, we just have a bunch of horizontal lines, so our derivative is equal to 0. Excuse me. Okay, so there is a theorem on the next page that formalizes all of this, but the two things that I need you to know from this page are that it's always parentheses for increasing and decreasing, and that you're reading it from left to right to determine increase and decrease.